Now, I want someone to draw a heart on the board. You. Well, that's a good try, but not exactly. Anyone else? Right there? Okay. Anyone else? Back there. Well, better. Okay, class, the heart is not shaped like your traditional heart.
Oh man, I thought I had it. I knew it wasn't that silly heart shape with assorted chocolates inside. Oh, chocolates. I could really go for some chocolate right now. Stay focused, stay focused. Okay, so the heart has chambers and valves and portals. Wait, what? Portals? Come on! The heart pumps blood from our body. No, wait, to our body. Or is it both? That date went great last night. I really liked her. Do I like her, or does my heart? Do hearts like things? When are we being tested on this stuff anyway? I could really use some chocolate.
Now remember, your midterm on the heart and arteries is tomorrow.
Tomorrow? Well, is tomorrow. Better make sure we know this stuff. I'm headed to the lab now. Man, the heart is great. It's amazing. It's a machine that works day and night, pumping blood all over the place. Blood goes through the valves, chambers, veins, and arteries. Well, I'm headed to the lab now, but I'm gonna go get some chocolate first.
The heart is located within a space in the thoracic cavity called the mediastinum. This is found in between the two pleural cavities where the lungs are located. The heart is surrounded by a dense layer of connective tissue called the fibrous pericardium. If we were to cut that layer and turn it inside out, the inside layer is the parietal pericardium. The outermost layer of the heart itself is called the epicardium or visceral pericardium. The space between the parietal pericardium and the visceral pericardium is the pericardial cavity. It's the space into which the heart beats, expanding and contracting. Diving deeper, the muscular layer of the heart is the myocardium. Finally, the innermost lining of the heart is the endocardium. The heart is divided into 4 chambers. The top 2 are called atria, and the bottom 2 are called ventricles. The structure that partitions the 2 atria is called the interatrial septum. The myocardial tissue that partitions the 2 ventricles is called the interventricular septum. A key way to orient ourselves on the heart is to find the apex. This is the inferior pointed portion of the heart. Remember that it points down and to the left, almost pointing toward your left elbow if your arm is at your side.
There, much better. Oh, the heart's really fantastic, and not that complicated either. So, here's the apex. It sits facing down and to the left. Ah, to the left. Got it. That makes it easy to remember which way it sits in there.
Arteries carry blood away from the heart, while veins carry blood back to the heart.
All right, everyone, let's get this blood away from the heart.
Away from the heart. Away from the heart, everyone.
Away from the heart. Let's get this blood to the heart, everyone. To the heart, everyone. To the heart. To the heart. To the heart.
The 2 main veins that carry blood back to the heart are called the superior vena cava and the inferior vena cava. The superior vena cava can be found entering the upper portion of the right atrium. The inferior vena cava can be found entering into the bottom portion of the right atrium. The coronary veins are on the surface of the heart. The coronary veins drain into a large vessel called the coronary sinus. The coronary sinus is found midway up the posterior side of the heart and drains into the right atrium. As we've stated before, blood returning to the heart enters into the right atrium, which can be found on the right superior portion of the heart. On the anterior part of the atrium, we find a flap-like extension called the right auricle. This can also be found on the left atrium. This is known as the left auricle. Looking inside the ventricle, more ridges of muscle can be seen. These crisscross-looking sheets of muscle are called the trabeculae carneae. Extending from the trabeculae carneae is a small muscle called papillary muscle. These muscles are attached to the heartstrings, the chordae tendineae. Papillary muscles and chordae tendineae are important because when the ventricles contract forcibly during systole, these two structures work together to prevent backflow of blood into the atria. That way, blood flows into the pulmonary trunk from the right ventricle and into the ascending aorta from the left ventricle.